Unlike most cells of the body, the voltage difference in neurons is constantly subject to change. This serves as an efficient way to add and summarize all the activity among thousands of synapses. The more active synapses there are, the more voltage will briefly waver. Neurons send information by reversing their potential to send an electrical message originating from the cell body that travels to the tips of the axon. This signal is referred to as an action potential. It causes the inside of the axon to become more electrically positive than the fluid surrounding it for less than 1 millisecond. The process of making an axon less negative is called depolarizing. Only depolarization of a certain size can depolarize an axon, which is referred to as the threshold for triggering action potential. Inhibitory synapses allow negatively charged ions to enter the neuron, resulting in the neuron crossing its threshold and becoming hyperpolarized. Sodium ions measure how polarized the axon is. The gated channels they occupy are found only on axons, starting at the widest part where they join the cell body. This is called the axon hillock. Every action potential a neuron produces is the same in terms of voltage change, thus leading to the name all or none property of the neurons. As such, once a neuron passes its threshold, its action potential will be the same. After a neuron fires, it enters a refractory phase in which it must rest before it can fire again. The speed of action potential is affected by whether the axon is wrapped in myelin, a fatty substance that provides electrical insulation. Because this allows the signal to jump quickly from one node to the next, it is called saltatory conduction. Not all axons are insulated. Drugs such as heroin are referred to as agonists, drugs that activate receptors in the same way a neurotransmitter would. Other drugs are called antagonists because they bind to the receptor without activating it. Neurotransmitters are not the only chemicals utilized by the body. Hormones are released from one part of the body and enter the bloodstream, where they move on to affect other parts of the body. Glands that release hormones are called endocrine glands. The pituitary gland is also a gland that releases hormones that affect these endocrine glands. Hormones are capable of influencing behavior, such as triggering anxiety or depression. Drugs may affect behavior by stimulating regions in the brain that normally respond to hormones generated by the body.